This is a short tutorial for using graphical analysis. Let's start by using a sample data set showing the effect of study time on exam score. Before graphing, we need to identify the dependent and independent variables. The independent variable is the one over which we have experimental control and is placed on the x-axis, while the dependent variable is the one affected by the changes in the independent variable and is placed on the y-axis. Since exam score depends on study time should be placed on the x-axis and exam score on the y-axis. Column options may be edited by clicking on the three dots on the column heading. Options include the column title, units, and precision. By making the appropriate entries for the columns in the data table, graphical analysis will automatically update the axes labels. Next, let's enter the numerical values into the data table. Notice how the points are plotted as they are entered into the table. We can also see that the precision for the study time is 1 decimal place. This setting had been adjusted earlier while the column headings were being edited. A graph title may be entered within the graphing tools. By default, notice that individual data points have been plotted. It is generally desirable for a graph to fill up as much of the grid as possible. The default for graphical analysis is to auto-scale, but the axis scales may be manually adjusted if preferred. Clicking on the magnifying glass near the lower left is another way to accomplish auto-scaling. Generating a best fit line or best fit curve allows us to predict values for measurements that are not directly made. In graphical analysis, this may be done by going to the graphing tools and applying a curve fit. Notice that the default option is a linear fit. Next, switch on the interpolate mode. If we would like to know the exam score expected by studying 7.2 hours, click anywhere on the best fit line, move the slider to 7.2 hours, and interpolate the exam score shown in red. In this case, an exam score of 63 points would be expected. To determine the study time required to achieve 85 points, move the slider to interpolate the study time shown in gray. In this case, a study time of 11.4 hours would be expected. Note that the precision of the interpolated values reported should match the precision of the data collected in the table. Once complete, the file may be saved by clicking the document icon in the upper left-hand corner. Next, let's start a new experiment and look at an example that uses nonlinear data, the effect of investment time on account balance. In this example, investment time is the independent variable since it is the one that can be controlled, placing it on the x-axis. The account balance is the dependent variable since it depends on the investment time and gets placed on the y-axis. Once again, we should label the columns, adjust the precision, enter the values into the table, and title the graph. Next, try applying a curve fit from the graphing tools. Notice that the linear option is a poor fit. Let's see what happens when other fits are tried. Here's the proportional fit. It's pretty obvious this one doesn't work. Next, a quadratic fit. We can see that this one fits nicely. While we could keep on going down the line, the data encountered in this course should fit one of these first 3 curve fit options. Let's keep the quadratic fit and switch on the interpolate mode to predict values that were not actually measured. To find the account balance expected for an investment time of 25 months, click anywhere on the best fit line, move the slider to 25 months to interpolate an anticipated account balance of $45.71. To find the investment time needed to reach $34, move the slider, and we can see that an investment time of 11 months is expected. Once again, note that the precision of the interpolated values reported should match the precision of the data that has been collected. Once complete, the file may be saved by clicking the document icon in the upper left-hand corner. As we can see, graphical analysis is a powerful tool. While this type of analysis may also be done with Excel or other spreadsheets, Graphical analysis was designed for use in analyzing elementary scientific data. Should you have any questions on using graphical analysis, please contact your professor.